In the world of hand tools, electrical pliers stand out as both precision instruments and critical safety devices. Today we take you inside the manufacturing process of insulated electrical pliers, from raw steel through forging, machining, heat treatment, and final assembly. These tools are designed to handle wiring, cutting, gripping, and bending in professional electrical environments, so every step of production must meet exacting standards. It begins with high-quality tool steel, supplied in coils or rods, selected for strength, toughness, and wear resistance. The steel is cut to length and heated to forging temperature, then shaped under powerful presses or hammers into the basic pliers profile. After forging, the blanks undergo descaling and trimming to remove flash and ensure clean contours. This early phase ensures a solid structure and material internal integrity, essential for tools used by professionals in demanding electrical environments. Next, the forged blanks are machined, drilling the pivot hole, milling the jaws, broaching for grip surfaces, and shaping handles. Heat treatment follows, hardening and tempering the jaws and pivot zone to keep durability and spring-back consistent. Shot blasting and surface finishing remove scale, clean the surfaces, and prepare the parts for assembly. Two halves of the pliers are assembled around a pivot rivet or screw, aligned precisely for smooth action and jaw alignment. Insulated handles are added rubber or thermoplastic sleeves molded or applied to protect the user from electrical shock. Final inspection includes jaw gap measurement, alignment check, grip strength test, and sometimes functional testing under load. Every tool carries brand marking, model number, and traceability code, a sign of quality in professional electrical tools. From raw steel to a fully assembled, insulated pair of electrical pliers, this process blends heavy industrial forging with high-precision finishing and safety certification. The next time you pick up insulated pliers for wiring work, you'll know the journey they took. Engineered, forged, machined, and inspected to perform reliably in critical applications. Welcome to Klingelberg, a world leader in drive technology solutions, precision gearing systems, and advanced machine tools. In this video, we explore how Klingelberg delivers high-performance bevel and cylindrical gears for industries ranging from automotive and wind power to rail and heavy industry applications. At the heart of Klingelberg's offering lies its engineering and production of gear sets and machines, combining drive technology / customized bevel gears with cylindrical gear modules for global sectors. State-of-the-art grinding, cutting, and measuring machines produce gears with extreme precision, ensuring minimal noise, maximum durability, and optimal performance under heavy loads. Automation, closed-loop measurement, and digital solutions ensure every drive system meets the exacting requirements of modern powertrains and industrial gear units. Whether for electromobility, marine propulsion, wind turbine gearboxes, mining equipment, or train drives, Klingelberg's gear systems form the mechanical backbone of motion everywhere. Advanced metrology centers inspect every gear to micrometer accuracy, while software links real-time data to quality control and production planning systems. These capabilities shine in heavy-duty, high-precision applications, where reliability, long life, and low maintenance are non-negotiable. In an era of electrification and automation, the right drive technology matters more than ever, and Klingelberg stands ready with precision gears, global service, and engineering excellence. Today we enter a high-efficiency production line, where drilling and tapping tasks merge into a single, automated workflow. Located in Taiwan, this 6-station fully automatic machine from Weixin transforms raw workpieces into precision finished components, faster, smarter, and with minimal manual handling. The machine features 6 dedicated stations, each configured for a specific process, from center drilling and through-hole drilling to countersinking, tapping, and chip clearing. Workpieces are fed automatically into the system, indexed to each station in sequence. While one station drills, another taps, allowing continuous flow production across multiple operations in a compact footprint. With PLC control and fully automated indexing, each step is executed without human intervention, dramatically reducing cycle times and improving repeatability. At the heart of the system lies a flexible tooling platform. Drills, taps, countersink bits, and fixture modules are all changeable to match workpiece size and geometry. High-speed spindle drives ensure consistent cutting forces, while automatic height detection and tool brake sensors maintain quality control throughout. Whether producing small batches or high-volume runs, this machine adapts. Different workpiece sizes, variable thread depths, blind hole, or through-hole tapping, all handled reliably within the same automated cell. By integrating drilling and tapping into one 6-station sequence, manufacturers reduce fixture changes, setup time, and labor cost. This automation is particularly suited to industries such as automotive, aerospace subassemblies, industrial hardware, or any sector where high-volume, precision-threaded components are needed. The compact design, automatic loading/unloading, and programmable flexibility deliver productivity gains, ready to meet just-in-time production demands and OEM standards. When every second counts and precision is non-negotiable, this 6-station automatic drilling and tapping machine stands as a true enabler of modern manufacturing. In the world of heavy steel profile production, precision is not an optional extra. It's the foundation. Here we explore a fully automated straightening machine designed specifically for angle profiles, NPU, and IPE beams. These structural sections, produced by hot rolling, often carry residual curvature or twist. The straightening process restores geometry, reduces stress, and ensures seamless downstream fabrication. This machine uses calibrated rollers and alignment dies to feed profiles smoothly and center them accurately for straightening. Lower rollers are driven by a high-torque gearbox. The upper rollers adjust their gap hydraulically, enabling quick changeover for different profile sizes. Whether you're working with angles like 40x40x4 mm, NPU 180, or IPE 200 sections, this machine handles the transition with minimal downtime. As the profile passes through, the rollers correct deflection, twist, and bow, restoring it to straight line tolerance. Straightening such large profiles demands control. Each roller pair is servo-driven or hydraulically actuated, allowing height and angle adjustment to correct uneven warpage. A modern system uses recipe software. Operators select the profile type, and the machine sets roller positions automatically. This ensures the end product meets straightness standards and is ready for further processing, welding, cutting, forming, without distortion issues. For steel service centers, construction fabricators, or beam processing plants, this straightening machine offers major benefits. Reduced scrap and rework, because profiles arrive straight and ready. Faster setup and changeover minimize downtime between profiles. Larger profile capacity means you handle IPE, NPU, U channels, and angles in one unit. With this capability, manufacturing lines stay efficient, costs drop, and quality improves. From raw rolled beams to perfectly straight structural sections, automation, precision rollers, and smart controls make it possible. In heavy industry, geometry matters. With this straightening machine, you're not just correcting steel, you're enabling performance. From a rough, rusted steel bar to a polished, high-precision feed screw, every stage of this process represents decades of engineering expertise. At Glycon Corporation, Michigan, USA, these screws are built to power plastic extrusion and injection molding machines that produce thousands of products we use every day. The process starts on a lathe, turning the raw, forged bar into a perfectly round blank. Each piece must meet strict diameter tolerances before moving to the milling stage. Next comes channeling, a CNC-controlled operation that carves a deep helical groove down the screw's length, shaping what will become its spiral flights. To withstand the extreme abrasion and heat of molten plastics, hard-facing alloys and carbide materials are welded along the flight edges. These materials form the wear-resistant surface that ensures the screw's long service life. After welding, the screw is slow-cooled for several days to relieve internal stresses. Then, precision grinding machines bring the outer diameter and channel geometry to micrometer accuracy. Multiple polishing stages remove every imperfection, resulting in a smooth, mirror-like surface that prevents plastic from sticking during processing. Finally, the screw is chrome-plated, balanced, and machined with its custom drive end to fit perfectly into the extrusion barrel. Each finished screw is a masterpiece of machining, engineered to perform reliably under pressure, rotation, and heat. This is Glycon Corp, where American precision turns steel into the heart of the plastics industry. Meet the DIVI MECLE612, a robust coil processing system designed to handle heavy metal coils and convert them into high-quality flat sheets or strips for downstream manufacturing. Engineered by DIVI in Brazil, this machine blends precision, speed, and durability for industrial operations. The LE612 processes incoming steel or aluminum coils, unwinds them precisely, levels them smoothly, then sends the material through high-speed slitting and recoiling modules. Its automated feeding and tension control ensure flat, wrinkle-free material even at high throughput. With heavy-duty construction, the machine maintains alignment, minimizes deflection, and supports continuous operation in demanding production environments. Whether supplying appliance manufacturers, automotive lines, or architectural sheet processing, the DIVIM ECLE612 stands ready to optimize yield, reduce scrap, and streamline coil-to-sheet workflows. When Kaman Industries was commissioned to create custom chandelier fixtures for the United Methodist Church in Plano, Texas, they turned to Acme Metal Spinning, one of America's leaders in large-scale metal forming. This ambitious project required massive 93-inch diameter aluminum bowls, each forming the core of the sanctuary's lighting structure. To fabricate these oversized components, engineers used Acme's 140-inch metal spinning lathe, among the largest in the United States. Each bowl was formed from a 96-inch square sheet of 1/8-inch thick aluminum, a material so large that only metal spinning could deliver the required strength and geometry. Acme first developed a laminated wood tooling pattern using CAD design, then machined it in-house before beginning the spinning process. Mounted on the gigantic lathe, The tooling and sheet were carefully formed into their precise curvature. Within 8 weeks, the team completed 8 bowl assemblies, including tool construction, spinning, and polishing. For over a century, Acme Metal Spinning has supplied custom solutions for lighting, aerospace, cryogenic, and chemical applications. This project stands as a shining example of American craftsmanship and the art of precision metal spinning at monumental scale.